where we'll just get familiar with what is Teradata, why Teradata, when we have other databases, and then has someone joined the meeting? Hello.
Hello, Sagar.
Hi, good morning. This is Sagar.
Hey, Sagar.
Yeah, good morning. Sorry, a
Um,
little bit late.
no problem. So we were just starting, so maybe Sagar, we'll have to drop off in another 20 odd minutes. Right, we'll
Okay.
start right now, and then I'll discuss with you on your specific requirements and on your background. Okay, since Binod also will have to
Okay.
drop off. So let me just start, and then we will have a quick round of introduction with you. Okay,
Mm-hmm.
right. So I hope Vinod and Sagar, you're able to see my screen now, right?
Yes.
Okay. Put it on clear mode. So okay, so in this session we will see we'll just have a brief introduction of Teradata, how the Teradata architecture looks like, and then how do we store data in the Teradata database, right?
Mm-hmm.
Agenda, Teradata component and architecture, objects and space allocation is something which we will not cover for now, right? And then data storage, we will see how the data is stored in the Teradata database and how it differs from from other RDBMS like Oracle or DB2 or MySQL or anything, right? And then index and data protection is something which we will see later because these are some of the advanced concepts, right?
Okay.
So what is Teradata? So again, if you see, Teradata is like any other RDBMS, but it was specifically designed for enterprise data warehousing. So if you see normally, right, other databases like Oracle and all, they are designed for web development, right? So most of the web applications they use Oracle in the background, right? However, Teradata was specifically designed for data warehousing purpose, right? So you will rarely find any website using Teradata as its background database, right? And again, Teradata is huge in terms of storage, right? It supports data of terabytes to be stored on the system, and then it's a massively parallel processing system. That means everything that you do on Teradata runs in parallel, right? In contrast with the other databases like Oracle or any other thing where things run sequentially. So once I show you the architecture, you will be able to understand what do we mean by massively parallel processing and how does things happen in parallel. What is the difference in the architecture which supports this parallelism, right? And then as I was mentioning, parallelism throughout the platform. So anything that you do right from storing the data till retrieving the data from the database, everything is done in parallel. Right, and that's how you get very high speed query processing capabilities as well. Share nothing architecture, so none of the resources are shared, and I'll show you one diagram where we will understand what do we mean by share nothing architecture and how this architecture is put in place. And then linear scalability. That's when your data grows in size, you will have to scale your data warehouse, right? And then the scalability is very easy in Teradata. You just have to add certain memory and then you're good to go. Right? So any questions so far?
Mm.
No. No? Now the next question comes, why do we go for Teradata when we have a lot of other databases in market? Right? So some of the capabilities, if you see, first one is around the capacity, as I was telling you, right? So Teradata handles data in terms of terabytes and gigabytes. I mean gigabytes and terabytes, right? And it can process all of that data at a very fast pace because of the parallelism aspect, right? And then the scaling becomes easier, right? Whenever you have a requirement to scale out your database, you can do it easily, right? And then parallel processing, so it is faster than any other relational database system available in the market today in terms of query processing, right? Because of the parallel processing capabilities. Single data store, so it can be accessed via network attached and channel attached system. So those are just the two different ways in which the Teradata can be configured, and then users can connect to it and then query, right? And then it supports the requirements of many diverse clients. This will be again a common feature across all the RDBMS, right? And then fault tolerance. So it, mhm.
What exactly is channel attached, and what's the difference with the network attached?
This is something we will see in some time, Vinod. So how does it differs, right? So that's again once I tell you the architecture, right? Probably I can explain you better. So now if I tell what is the difference, then it might be confusing for you. Okay.
Okay.
So the next one is around the fault tolerance. So it automatically detects and recovers from hardware failure. So you would have heard terms like RAID, right, or database mirroring, right, to have a backup of the data that you have on your database. So in the similar way, we have an automatic fault tolerance capability in Teradata, which we call it as fallback protection. So while you define or while you create a table, you can specify whether you want a fallback protection or not. And once you specify it, automatically the fallback protection is applied. And then if your one of your nodes goes down, you'll still be able to access data from the other nodes. Right. So I'll explain you that how does that helps. How does you retrieve the data from other nodes when one of the nodes is down, right? And that's where the beauty of the Teradata architecture lies. And then data integrity, just like any other RDBMS, right? Either the transaction is complete or it is not done at all, right? And that's where you maintain the data integrity. Scalable growth, we have been discussing about this. So allows expansion without sacrificing the performance. And then SQL. So SQL again, so any RDBMS, they have to follow the ANSI standard of SQL, and apart from that, the vendors, they can add their own capabilities. So Teradata is fully compatible with all the SQL statements, whatever you have been using in your earlier databases like DB2 or Oracle or MySQL or SQL Server. Apart from that, Teradata does have certain additional features which are much more flexible than any other database, right? So once we start learning about SQL, we'll see what all are those additional features which Teradata provides apart from the ANSI SQL support. Okay. So any questions on this? I know Vinod has a question on the network attached and channel attached systems. So apart from that, do we have any other questions?
What is this parallel processing exactly?
That we'll see in a moment, Sagar. How does the parallel processing and what is the Teradata architecture? So then you will come to understand.
Okay.
We'll just see in a moment, right?
Alright.
So now we'll get to understand what are the Teradata components and architecture. So this is where I was coming from. So in well-known RDBMS or any other RDBMS except Teradata, you have a shared everything architecture. That means you have all these units of parallelism here and they share the common data, right? So you have only one disk storage which is accessed by all other units of processing, right? So here the scalability becomes difficult because all of them are using the same disk space, right? Whereas if you see in a shared nothing architecture, which Teradata database follows, so all of these units of processing, they have their own disks allocated to them. So in case you want to scale the system, when you need more storage, you just have to add one more node like this and one more disk or data partition like this. So you don't affect any of these existing architecture, right? And that's how you can scale easily without hampering the performance, right? And then if you see all of these, so this node and this node, they are connected by a single communication line. But in effect, this node will not share the data which this node uses, right? So this node has its own data partition, this node has its own data partition, and so on. So none of these nodes they interfere with any other data partitions which are used by other nodes. And that's how it's a shared nothing architecture, right?
So in the previous slide, we were saying, or maybe in this slide, we were saying scalable, or maybe it's with the fault tolerance, right? You're
Right.
saying automatically detects and recovers from hardware. So if a node fails, and if
Mm-hmm.
that's the only node that's connected to a partition, how
Yes.
how does how does it recover?
That's where we will see here in this process we will see how does it happens. Okay. So what we do is let me just give you a background. So when you have a table, right, you don't store the entire table data in a single node. Instead, you distribute the table data across different nodes, right?
Is it a copy that you distribute, or is it?
It's not, no, it's not a copy. So what will happen is, see, when I'm saying that there is a fallback protection enabled on this node, that means whatever data you have, a copy of that data will also be stored in a table called as fallback table, right? So now what happens is if this node goes down, and or let's say if this data partition goes down, your disk is not working, right? So that fallback table data can still be accessed. That's a backup that you are creating for each and every node. I know again that comes with a price of using more memory, but that's how Teradata provides you a backup, right? And to your question on the data copy, so we do not copy. So for example, let's say in a table you have 100 records, and then I have a 4 node system, right? So each of those nodes, if the data is distributed equally, each of those nodes will get 25 records, right? We don't store everything on a single node. So even if let's say in the worst possible scenario everything goes down, you don't lose out the you don't lose out 100% of your data, right?
Okay.
Okay. So this is like massively parallel processing loosely coupled. So you can have multiple nodes with their own disk. No nodes. So if you see, the only common way for these nodes to interact with each other is this communication channel interconnect. And this is where your network ATAS and channel ATAS systems will come into play. So there will be only one communication channel via which these nodes interact, but apart from that, they do not have any other mode of communication with each other, right? They do not share each other's CPU, they do not share each other's memory space, right? And whenever, and since, as I was telling you, right, if your table has 100 records, and if I have a 25 node system, sorry, if I have a 4 node system, each of those nodes, if the data is distributed equally, will get 25 records each, right? In that case, whenever you are trying to retrieve the data, you'll have to retrieve the data from all of those nodes, and that can be done in parallel because those 25 records which each of those nodes are having, those are mutually exclusive, right? They do not have any dependency. So all of those nodes can process the query at the same time, and that's how you save time, and that's how you implement the parallelization, right? Whereas in normal RDBMS, if you see, since everything is shared here, since you have only one data partition here, it will take time for each of those data to be retrieved, right? Whereas since you have different data partitions here, all of those nodes can trigger the query in parallel without waiting for the other to complete. Are you clear on this, or you have any doubt?
Good. So the other thing is that if one of the nodes is down, then
Mhm.
you won't get the result set for any query because you need all nodes to be functional, right?
Yes. So there is a concept called as clicks in Teradata, right, where the data in one node is replicated across other nodes as well, and all of those nodes they form a group called as clicks. Okay, so even if your one of the node is down, you can still recover the data from the other node. So that's the replication that is being done when you go for the actual Teradata implementation,
Okay. So
right? And there you will have a metadata saying which part of the table is stored in which of the nodes, and that data is replicated across which other nodes. So using that metadata, you can recover your data from the other nodes.
okay.
Okay, yes, you had a question.
Now, does the person who's writing the query have to know what nodes is connected to where and all that, or is it all?
No, 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 no. So a person who is writing a query or who is working on the database, he or she will feel like working on any other database. But in the background, these all things happen. So at least you should understand that how your data is getting distributed across all these nodes because it's a distributed system, right? So at least you should understand how the data get distributed. The reason you should understand is because if you need to define a proper primary index. So when we come to Teradata, we don't have a concept of keys as you have in any other database, right? So the data is distributed based on the indexes that we define on the data. So if you do not understand about the index, or if you do not understand the implication of defining a improper index, then you end up having a very bad performance in Teradata, right? So all the data distribution across these nodes, the one which I told you, right? If there is a even distribution of the data, and if you have 100 records with 4 node system, each node will get 25 records. How does that decided? Right? That is decided by the index that you define for the data. So if you are defining a proper primary index, then the data will be distributed evenly across all the nodes, right? So to do that, you have to understand the Teradata architecture. If you do not understand how your data is stored across nodes, you will not be able to define a proper index, right? But after that, once you start querying and all, it's like any other normal RDBMS system where you don't have to worry about from which node the data is being pulled, or which node is not responding or anything. So that's again a job of a DBA, or the infrastructure team who is managing this entire architecture, right? Right? Am I clear, or did that answer your
Yeah.
question?
Yeah, it does.
Okay. Teradata software architecture. So this is how a Teradata architecture is being done. So you have a channel. I think this one now you know what is a channel connection and what's a network connection. So channel connection is available for mainframes, right? And then network connection is for the LAN. You can have both the connections on the Teradata RDBMS system. Right, Binod? Did you get that? Because mainframe, I don't think it supports LAN, right? It's always a channel attached system.
Oh, okay. So you can connect a mainframe to a
Yes,
Teradata server, right?
yes, yes.
You know what is needed on the mainframe? Make that happen?
Not sure, not sure. I don't have experience on the mainframe. Maybe I can find it out for you, right? And then I can respond back. But for now, I'm not sure what is needed in mainframe to connect to Teradata because I've never done that.
Yeah, that's fine.
Okay. Okay, so this is about the connectivity, and then you see something called as PE. So PE is known as parsing engine. So what it does is whatever queries we write on Teradata, we actually work on this PE part. So this parsing engine will check whether you have given your syntax properly or not, and it will optimize the query. So basically, whenever you write a query, this parsing engine will form a query execution plan, which will see what is the best way to execute a query and what is the fastest way to execute a query. So all this optimization and all is done by the parsing engine. So there are three main things that a parsing engine will do. First, it will check whether you have access to the particular table or not to which you are querying. Right. Second thing, it will check. the syntax of the query that you are writing, and the third thing is your resource management or the query optimization, which it will do, right? So whatever queries we write, we actually work on PE, and then you have a VNet or a BiNet channel. So this is the communication channel for these nodes, right? And these nodes we call it as AMP in Teradata, Access Module Processors, right? And they are connected with their own virtual disks, as I was explaining in the previous slide, right? And the only way where these nodes can communicate with each other is via this BiNet channel. Okay. So, and this BiNet is again a bidirectional channel where once you give an instructions or once you write a query on the PE will form an execution plan, and then it will send that execution plan via BiNet to these nodes, okay, via BiNets to these nodes, and then each of those nodes will get the request and they will process. Once the data is processed, they will send back the data via BiNet to the console where you will be able to see the data on your screen, right? So all the communication between PE and AMS happen via BiNet, and it's just a communication channel. It does not do anything apart from connecting all these nodes and with the PE. So it's just a bidirectional way where it takes the instruction, gives it to AMP, takes the data or the output from AMP, gives back to the PE or the console output, right?
Is that
And
the
in a Teradata architecture, you
is that the short form of
go ahead,
something?
Vinod.
VNet and BiNet?
Channel.
What is-
Oh, I'm not here.
I'm not able to hear you, Vinod. Can you come again?
I was asking if the VNet and BiNet is a short form of something. What does it actually stand for?
BiNet, no. So it's I mean, VNet, I know virtual network kind of thing, but BiNet, this is like a bidirectional communication channel only. So there is no specific full form for it. So that's the communication channel known in Teradata, right? And then you will have actually two BiNets. So there will be two 16 MB communication channels in Teradata, in any normal Teradata architecture. Okay. So any questions on the architecture? Hello?
I'm good.
Okay. So this is again AMPs. So right, you have these AMPs are nothing but the nodes which I was telling you. So you have B1, AP2, 3, 4, right? You have a 4 node system, and this diagram shows you what all an AMP does. So it does the data loading, indexing, writing, lock, row lock, sort, aggregate, transaction, journaling, backup, and recovery. So all these operations are performed in each of those AMPs because each of those AMPs they have their own disks or data partitions, right? So each of those AMPs they will have to perform all these operations in parallel again. So whatever we do in Teradata that is done in parallel because of the independent data partitions which each of these access model processors have, and that's how you get a very high performance. Okay.
So all that you just mentioned, that aggregation, sorting, all of that all need to be done at a BiNet level also, right? Because you only get a one piece of the result set back in
No,
from.
no, that is not required to be done at the BiNet level, and that's the beauty. So in Teradata, everything is stored in random and it is retrieved in random. So you cannot expect that if I am entering 1, 2, 3 in the sequence, I will get the data 1, 2, 3 in sequence. You can get the data 2, 1, 3 or 3, 2, 1 or 3, 1, 2 or any other sequence. So that's how in a normal DB2 or RDBMS, if you insert a record, so that's like first in, first out, right? But in Teradata, it is random. You don't get things in a sorted order. If you want to get things in a sorted order, you have to explicitly use the order by clause. If you do not use order by clause, you will get the data randomly. You will get all the data, but you'll get the data randomly. It is stored randomly and it is retrieved randomly. Okay.
So
So
in the
sorting is only done at the AMP level, not at the output, the output you see. Right.
so what happens if you specify order by? In
So
the previous
when
example, saying a table with 100 rows, 25
okay.
records each goes into different AMPs, and you need it in a certain sorted order. Where does that sorting happens, the final sorting?
So that final sorting will happen in a memory space called as temporary pool. So they have, when we will study about the different kind of memories which we have in Teradata, you will be able to understand. So there will be different spaces, parm space, temporary pool space. So all the sorting and all happens in the pool space. That's like a buffer, right? So there also you have to use proper index. So if you are not using a proper index, right, the sorting may take a lot of time, or it might take the entire buffer space, and there you will have issues like buffer run out of memory and all that. So those are some of the common issues which we face when we work in real time if the indexes are not defined properly. Everything right from data distribution till data sorting, data retrieval, everything depends on how uh, intelligently you define an index.
That is still happening after the AMP, each AMP passes the data back to Binet, or before that?
So
The sorting in the pools that you just mentioned.
the memory,
Yeah, yeah.
so that will happen before the Binet passes the data, because Binet is just a 16 MB communication channel. It do not have any other capabilities. So all those things will happen before that.
But but the AMPs are not talking to each other, right?
No, AMPs are talking to each other via Binet, not directly. So if you see, if this AMP wants to talk to each other, it can go to Binet. Binet can send this instruction. Then Binet can take the response, and then it can give the response back to this AMP. So it has to go via Binet. There is no direct communication channel. So if this has a request, this will send it to Binet. Binet will send it to this AMP. The response from this AMP will go to Binet, and Binet will send it back to this AMP.
So if a piece of data is coming from AMP1 and the other piece is coming
Mhm.
from AMP2,
Right.
where does it put it together? Where does that happen?
That's on the temporary space, right? That I have not shown you here, but that's on the temporary space that you have, right? It's not like it's not like that the binet is directly connected to AMP and you don't have any memory, right? See, there has to be some connection with the AMP, right? How do we connect the binet with the AMP?
But it's still only with one AMP, each AMP separately, right?
Yeah, that's all. See, the data will be retrieved from each of those AMPs, right? And before the Binet even sends the data, it has to combine the data from all these different AMPs, right? And that's where your pool space will come into picture.
Okay, so that's happening in Binet, or it is, it has that control or
Yes,
responsibility.
yes.
Okay,
So any communication that happens through Binet. So any communication related responsibilities lies with Binet only.
okay,
Okay. So this is on the architecture, and then I think I'll have to stop it for today, and then the data storage maybe we can see in the next session.
okay.
Right?
So, do you give any material with this training?
Yes, so you will get these presentations along with the detailed notes as well, right? And then after each and every lesson, we will have exercises being done, quizzes, intermittent quizzes to make sure that we are all on the same page and we are following. Right?
Okay.
So materials you will
And
get, so no worries on that. All these presentations plus the detailed notes, because these just have diagrams, right? So the detailed notes also I'll send you.
okay. So if we do something hands-on, where does that happen?
So that we will have to, I'll guide you through the process where you have to install Teradata on your system. So that's available to download for free from the Teradata website. So we'll install that and then we'll practice all our queries there. All right,
Okay. All right. I'm good.
cool. Sagar, you have any questions?
He's on the road.
Oh, I think so. Sagar?
So how long is each class?
And there'll be 1 hour each. So today is just the introduction. So and then I had to run in half an hour. So that's why I stopped. But normally the classes will be for 1 hour.
So is it like once or twice a week, or is it daily?
That no that is something which we can decide. That is something which I cannot decide because you will I'll have to understand your availability as well, and maybe three odd classes per week should do, and the timings and all we can decide where every one of us are comfortable. Okay? And that is something I mean you can talk to Subhas as well because I just don't want to give a timing and then where you will not be comfortable. So that is not going to work out, right? We have to respect each other's times. That we can decide. I
So
think
this
Sagar is having some communication issues. Yeah, Vinod, go ahead.
when you showed the topics on the first page or so, I didn't see
Mhm.
anything. Maybe it's me. I didn't see anything specific to all that utilities. Is that going to be part of it?
So yes, so I'll show you the contents sometime later because I'm still preparing the contents, right? But utilities are a part of this. The presentation which I showed you, that's only for the first lesson where we get the introduction about the Teradata. Okay, and that's the reason you did not see anything on the utilities. But utilities will have a separate chapter. So we will cover BTQ, fast load, multi load, and fast export.
Okay. Okay.
And each of those will have I mean their own different lessons. So BTQ will be one lesson, fast load will be one lesson, fast export will be one lesson, and then multi-load will be one lesson. So that is there in the agenda because without that setting Teradata does not make sense because SQL anyone can work with on Teradata. Right? It has fully support SQLs. Right? So utilities are the most important part of Teradata. So that will anyways be there.
Okay.
Okay.
All right.
All right, Vinod. So
All
if you
right.
have no other questions, we'll wrap up for today, and then you can just get in touch with Subhas. I'll also talk to him, and then we'll figure out when will be our next class, and then we'll continue from there. Okay.
All right. All right. Thanks, Anup.
All right. Thank you, Vinod.
Bye.
Subhas, hello. Subhas, are you there?
Yes, Anup.
Subhas, I'll call you back in some time. Okay. So we are done for today,
Okay.
and I'll call you back in some time, and I'll have to run now. So
Okay.
I'll call you back after some 1 hour or something. Okay.
Okay. Binaj, uh, hello, Binaj.
I think it dropped off.
Okay. Pl- one. Hello, Anup.
Yeah, tell me, Subhas.
We have a one query from US candidate. He asking job support on Teradata,
Okay.
so that I
Uh,
handle it.
right.